Okay, so welcome to today's video. Today we're going to be talking about how you would go about debugging a crash like this. So this user brought this up yesterday. It says basic REST example crashes and has no clue what's going on. Looks pretty basic. We have tons of REST users in prod. Some of our customers I know use REST really heavily. So I knew it wasn't anything really to do with like REST itself when I saw this. But this stood out, this invalid opcode UD2. What this is really saying, this message right here is basically saying that it was given an instruction that it doesn't know what instruction it was or what it's supposed to do. So, if you scroll through the ticket, the very first thing I asked for on it was, the ops profile, the LSB release, and the uname. And that gave me some more information to kind of figure out what this user was actually running into. He looks fairly up to date on the ops profile, and there was no tricks there. Sometimes people will be virtualized, and then that throws in a whole different set of issues. But then I noticed he was running CachyOS. Now, I have Arch installed on a few systems, and I think I ran across Cachy before. But basically, this is like built on Arch, and they go out of their way to optimize stuff. I mean, they brag about it, right? So, but this in particular tells you that they're going to be using as new of instructions as they can on various things. And so like even like libc, they'll be using stuff like that. It's fine if you have a computer that works with that. It's fine if your code works with that. But if you don't have a CPU that can make use of these instructions, then you're up shit creek. All right, so right now I had a guess of what's going on, and I even kind of call it out. I say it's AVX 512 because they listed it on this page, right? But here's the thing: it was just a guess. I don't have access to the code, or I don't have access to his system. I have access to the code. And without having a system that had that, like a CPU that has that, I think the AWS T3 instances have this. It's kind of hard to reproduce. And so the first thing you want to do when you make a guess at what a bug is doing is you want to be able to prove it. And by prove it, typically that means reproduce, right? But like to validate your hypothesis as to what is causing that bug, that's what you want to get to, because only then can you solve it. A lot of engineers will like waste a ton of time because they'll guess and they'll guess and they'll guess, but they'll never actually like prove their guess. And until you prove it, you can't actually fix it. Anyways, enough of that. Let's go ahead and replicate a similar example. So he was running into an AVX 512 issue. This S1 box that I'm on actually doesn't have AVX2 instructions. And you can just do like a, let me see if I can find, do grep maybe. Yeah, grep AVX. Yeah, so you can do like a little grep for this in your proc CPU info, so AVX2, and you'll see that it pops up. These are the instructions that these cores support, or not the instructions, sorry, the sets. And so if you do the same thing on if you do the same thing on the other box, so we do cat proxy CPU info, and we try to grep for the same set. We don't find it, right? So we already know, because, and I know that this box is really old. It's like from 2013, 2014. So clearly doesn't have it. So we know it's going to crash on here if we try to call out to this instruction. Let's just pull up this code. I just grabbed this off of GitHub. I honestly don't know too much about the instruction set itself, but you know, this header and basically we're just going to add these together. Let me see about how we compiled this. So basically we're going to compile it like so. We included access to these instruction sets, and now we can run it. All right, so this is on Linux. It says illegal instruction, basically the same thing, exact same message saying, you know, have no clue what this AVX crap is. If we run it over here, we can see that it actually works because we do have access to the instruction set. This is a newer computer, the Venus one versus the Swan one. Now, let's try to figure out what instruction it's puking on, because here we're playing the role that, okay, we know it's crashing, but why is it crashing? Like, what instruction specifically is it crashing on? Now, to get that, we're going to throw up this little config. And I've done a video about this in the past, so this is a kind of a newer version of that video, but essentially we want to get the core dump. And basically what that will do is just give us what's in the memory when it's crashing, and then we can analyze it later. I've set this to an arbitrary high value, saying, hey, give me no more than 150 meg of core. And then I need a base volume that's going to be higher than that. Now, this program is really small. It's like 15K, right? So this doesn't need to be this high depending on what you're doing. And then I've also disabled ASLR. So ASLR is a security feature. It randomizes library locations. It randomizes the kernel memory location. It randomizes the ELF file itself where it resides in memory. And so we turn this off for debugging purposes, just so we kind of know where all of our memory is at. You don't have to do this for this particular example, but if you don't, your information is going to be all messed up, and you're going to be wondering what you're looking at. So when debugging like this, it's generally better to turn it off if you can. Okay, so now we can go ahead and run this guy. All right, so let's do like something. Okay, give me something else. That's the last one. We actually wanted tell, right? Okay, enough hunting through history. Let's do ops run config main. Then I'm gonna pass it nanos version. I discovered the other day looking at this guy's ticket that we actually had a problem in dumping these cores, and we're gonna address that here in a second. But for now, 0147 will get you in the door. So we run it. It dumps the core right here. And now we can kind of do an ops tree main. Core dumps core, right? So let's go ahead and copy that out. Do main, core dumps core. Okay, so now we have our file. As you can tell, it's much bigger than the actual executable. Okay, and now you can do GDB main core. And so load the file and the core. All right, so now we have our information, and we can just do this like layout assembly, and voila, now we know these instructions were what was actually causing the issue. And if you do, you can go look it up here. Well, this is the other one, but anyways, you can look it up and see like which feature flag turns it on. In his case, it was clearly like this AVX 512. You can do this for any instruction, but that'll tell you what's going on. And so then, you know, it's just a process of asking yourself, does the system actually support it? So in the case of like 512, like I said, there are some AWS instances, like I think the T3s that support it, but like your average instance types don't, because it's a newer instruction set addition. Anyways, till next time, see you later.